Hi folks, I'm Colin Dean, and I'm going to tell you about a really cool documentation workflow that I came up with to help a group of data scientists and software engineers create a really awesome scientific document, and it's gone on to be reused by a whole lot of people. So here we go. I'm Colin Dean. I wear a hat and scarf at conferences very often. I'm generally wearing them, and I thought I'd put them on even for this recording just because that's what I do. So in that spirit, I'm wearing them now. Lawyers always say it's a good idea to display and say this, so I'll say it. The views expressed herein are my own and do not necessarily represent the views of my employers or associated organizations, past, present, or future. I work for Target, as you can see from my shirt as well. I am based out of our tiny little Pittsburgh office on Robotics Row in the Strip District. Like most other tech workers, I'm working from home during the pandemic, so I'm recording this from my home office in beautiful, abnormally hot Wilkinsburg, Pennsylvania. I run Code and Supply, a Pittsburgh-based organization of more than 6,000 software professionals. We run a co-working space in which we normally hold meetups, and we also run some conferences you may have heard of, such as Abstractions, or this week's upcoming Hardefacts conference. Check out hardefacts.codeandsupply.co for more information about our conference on mental health and community building for software professionals. I've been involved in MetaMesh since its humble beginnings as a bunch of 20-somethings trying to build a citywide mesh network. In 2020, we're actually kind of getting there as we pivot to being a nonprofit wireless ISP. Check us out at metamesh.org. Now for the real stuff. Our manager came to us one day and told us about an upcoming offsite meeting at which we'd be asked to present about the work that we've been doing. A part of that necessitated a write-up detailing how our product worked at a high level. And multiple people would be consuming it. We knew that we needed a well-designed document that could be easily read when printed, but also take advantage of the various aspects of the hypermedia that we were going to use to distribute it. We'd most likely deliver it as a PDF, but a long web page wasn't off the table. We knew that we needed to provide good content, but it needed to be well summarized and also be navigable. Then, all of a sudden, there was a big change. A development pause. Our product development was paused, so we needed to document everything. It may not be our team that continues development whenever development may continue. With that development, our scope grew, and we had to go a lot more in depth to capture the knowledge for our team, from our team for posterity's sake. For example, what we'd intended to be a work, the depth of a quick tour of a house, turned into being an owner's manual documenting every little quirk and hidden compartment. There are 7 of us, mostly co-located. Normally co-located. Mostly co-located as well. A couple of us live a little bit outside of Pittsburgh. We each had different concerns and interests to be recorded in the document. The engineers needed to show how the product works, as well as how it's deployed as production software. The data scientists needed to show the business logic behind the software, including equations and citations, with a veritable cornucopia of acronyms, initialisms, and other terms likely to require a glossary. We needed something that we could all easily use and contribute to simultaneously. After all, we had just a handful of days to complete this document. We needed a workflow that would get out of the way and let us focus on the content while still looking professional. It's a good practice to figure out the things that you value about a system before you actually start building it. When I'm building software, after the initial idea comes, but before I start engineering a system from it, maybe I've implemented a few lines of code or a small proof of concept. When I start thinking about the system, I want to think about quality attributes first. So, of course, I applied that practice here. We assumed that a lot of our content would be text and diagrams and equations. We wanted an easy markup format that would be easy to write, easy to read, and preferably didn't require a special program to read. That is, we wanted it to be reviewable on GitHub as text. And we wanted it not to be in control of the styling within the document. except for perhaps some semantic markers calling out special sections. We wanted to be able to use LaTeX if we needed it, because we also knew that we might want to draw a diagram using TXZ, one of the diagram packages for LaTeX. Lastly, it needed to be of easy use for both humans and computers. One command should be necessary to build the document, and we could treat that document as a build artifact that is versioned and archived. The key idea is this. This concept of treating documentation as source code is probably not novel for most seasoned documentarians. But those for whom documentation is all too often an afterthought, like many engineers and data scientists, this concept is life-changing. There were some things we wanted to avoid. This basically eliminated the things that we wanted to avoid. Effectively eliminated Word, Apple's Pages, straight up LaTeX, Confluence Wiki that is widely used in the industry, and virtually every less well-known text format, such as AsciiDoc. We considered some of the newfangled tools like MDBook, but found that they didn't really have the quality of PDF output and the integration of the niceties of the Pandoc ecosystem. That's right, we really wanted to avoid this. The team really despised working in Word and strongly wanted to avoid authoring anything in our wiki system, which we treat as ephemeral and quickly out of date at any given time. So I came up with a solution with all of these values in mind. We built a solution based on this stack in about 2 weeks, also while writing the prose. What we got is the simple text, easily read, reviewed, and agreed upon through our established systems of consensus, and produced the same way every time. It could even automatically notify stakeholders when we release a new major version. This was super important to telling our boss, hey, we actually did some work this week, when all we were doing was working on this document. The biggest benefit, though, we basically got LaTeX typesetting without having to suffer through LaTeX. Any of you who have worked in LaTeX at any point know that you can be productive in it relatively quickly, but you end up fighting it at some points to try to get things to work the way that you really want them to work, to get things to display the way you really want them to display. We didn't have to do that. Our final document actually had very little raw LaTeX inside it, outside of a couple of equations and a couple of diagrams that were simple enough that we could quickly redo them in TXZ instead of leaving them as PNG or SVG images. So let's talk about Pandoc, the Universal Document Converter. Pandoc was started a while ago and hit 1.0 in 2008, with the 2.9x series release just coming out just before we started working on this documentation project. Pandoc itself is written in Haskell, but supports a Lua scripting engine for writing plugins that process the abstract syntax tree that Pandoc uses as an internal representation of the dozens of document formats it can read and write. Some Pandoc basics. It's really easy to install. Pandoc is available in virtually every package manager, and there are also downloadable installers available on pandoc.org for Windows folks and other operating systems as well. Here's an example of an invocation. Pandoc attempts to figure out the input and output formats based on file names, but it's sometimes often better to be explicit. In some cases, you need to be explicit whenever you're turning on various optional extensions for Markdown. This is an example of running Pandoc in a very early version of these slides, which is conveniently also written in Markdown and uses Pandoc to produce the code which comprises this presentation. Here's a longer real invocation. This is a copy-paste out of our build system. We break down chapters and sections into separate files, and Pandoc automatically concatenates the input. Note the use of filters here, the choice of PDF engine that enables XE LaTeX, which is a packaging of LaTeX, in order to use Unicode and some other implementation-specific features only available in XE LaTeX, or ZLaTeX, is what some people call it. Note the choices about table of contents, section numbering, lists of figures and tables, and of course, the ever-present bibliography. Command line metadata options can be put into the YAML front matter of the document. For those of you unfamiliar, it's a common convention to put YAML, a small YAML block at the top of a Markdown document as a source of metadata. This is common in static site generators. You see it on GitHub all the time. Here's an example of that. Metadata and some other options for specifically for Pandoc can easily go into the YAML section at the top of the document. Pandoc also supports a configuration file containing some defaults. I use this whenever in some newer projects, whenever I want to shorten the make file. Makes it a little bit easier to have smaller amounts of text in your terminal whenever a build process is running. Reveal and PowerPoint are supported for first-class output for presentations. Of course, also LaTeX Beamer. It's a output format that uses LaTeX to build a PDF that is really good for presenting from. Eventually, you're going to have to find some way to build this. It becomes a little bit unwieldy to have a very long Pandoc command. A lot of command line options you can put into that configuration file, but there's still going to be some things that you need to not have in there. Any sufficiently advanced build script eventually turns into make. So I usually just kind of reach for a make file. Gradle has some plugins that work pretty well for this that automatically can pull down Pandoc as a package. But make is probably the right tool to use most of the time. Some common plugins for Pandoc. We've used SiteProc and Crossref extensively. SiteProc is included in many distributions of Pandoc. Crossref is a separate external plugin, but it's widely used. Some other great plugins that I've used include code pulls in some files, which is great for pulling in snippets from an external file that might change over time. For example, you want to pull in a couple lines from one particular source file and reference that in your prose. You can do that very easily with include code. I'm making extensive use of panpipe in a workshop that I put together. I could put code examples directly in the document, then write those examples to a file during the document build process, and subsequent code blocks are able to use those files written to that temporary directory to do more things. For example, this workshop that I'm working on is a thing for doing plain text accounting, and you can put transaction records in one block and then manipulate that file in subsequent blocks. It's a really cool system. These two together, as well as place table for nicely rendering CSV data, are just fantastic changes for presenting data and code together. For more plugins, I strongly recommend using Lua if you're going to write something. It's a whole lot easier to read and a whole lot easier to set up than a complete Haskell build environment. There's also Python filters. Really anything that can read and write JSON is able to process the abstract syntax tree. So you could write it in anything, but there's already libraries available that are able to manipulate that JSON object in language-specific idiom. Images can be, you very easily use images in Pandoc. Images can be in a variety of formats. I tend to convert everything to PDF, especially if it's like an SVG. I'll convert it to PDF before including it in and reference the PDF specifically. That way I know that the PDF will look right versus SVG, because SVG output rarely correctly converts fonts. When using Pandoc, you have to use kind of web-safe fonts in order to get it to work. Here, the example on the slide at the bottom, I redrew a diagram that we have been using in our presentation or in our document using TIKZ or TIKZ. It looked a whole lot better when we redrew it in Tixie using scalable primitives, instead of this ping that we had taken a screenshot of and embedded in the document. It looks a whole lot better. It scales better. It prints better. Higher quality. That's what a lot of this is about. Using siteproc that I talked about earlier, Pandoc siteproc, we were very easily able to enable bibliographical references. So the next part of this is Git. You've probably heard of Git. It's kind of an industry standard these days. Git was originally written to manage Linux kernel source code. Linus Torvalds himself wrote it. But it was really actually popularized in the late 2000s and early 2010s by this little company called GitHub. GitHub, for those of you who haven't heard of it, is a widely used public website with an on-premises version called GitHub Enterprise. It's increasingly used by large companies. It's a source control management system and centralized repository for what is hilariously a decentralized version control system. Next, I'll tell you about how my team used these powerful tools to create a workflow that enabled us to collaborate without having to pass around a file and constantly rename it. We use these 4 primary tools: Pandoc, Git, GitHub, and any CI system. Us specifically, we were using Drone, a container-based continuous integration system. Target now uses another one internally that is actually open source, but I don't know if we really talked about it publicly very much yet. This is the flow of data around a Git repository system. Those of you who are familiar with GitHub probably recognize this workflow. It's important to note how changes move around the system. You'll note that you clone data from GitHub, make some changes to it in your working copy. Pandoc compiles it, you fix any problems, and then you commit your work, push it up back to GitHub. GitHub sends a message to CI where it checks Pandoc runs in CI system, saves any build artifacts or communicates a broken build status, and then releases an artifact. It's a pretty slick workflow. Automation is great. We don't like humans involved in actually building the documents and building the binaries that we're going to ship to a user. When you're going to write Markdown, there are some specific Markdown text editors out there. I'm a big fan of Markdown, but all too often I just end up falling back to Vim with a few good plugins for easy editing Markdown. 1 sentence per line when you're actually writing the document makes it a lot easier to suggest small changes during the review process. You make a one-word change or a 1-sentence change, which is where most changes will come in. Git handles that a whole lot better than a large paragraph of text. When you limit relevant content to a single file, you can definitely extract a single chapter or a few into a single PDF. This is great for a summary PDF or for testing only one file in a large document. Our final paper, which is about 45 pages, takes about 12 seconds to compile on my 2019 high-end MacBook Pro. Compiling with only 1 section takes about 2 seconds. A lot faster to produce something that you're only working on a very small section of. When you're writing commits, anytime you're using Git to write commits, you should do this for source code documentation. You want to use Git commits to tell a story about the changes. Maybe a lot of things in prose are going to be fairly self-evident and maybe describable in 1 line, but maybe you need to have a discussion or a longer explanation about that change in the Git commit. That's the appropriate place to do it. Next up, we'll talk a little bit about reviewing. I do a whole talk about code review and pull requests and their relation to architecture. So I suggest doing some further reading or watching. You can find it online by searching Colin Dean code review on your favorite search engine, hopefully DuckDuckGo. Use automation such as GitHub's code owners file in GitHub or some other automatic assigning system. I think there's auto-assign bot on public GitHub that I've actually contributed to. Anything that can automatically assign somebody is going to bump somebody to actually go and review the work much sooner than just leaving it there. I will tell you this. Every time I've not set up CI on a repository using this template, someone has managed to merge something to master that breaks the PDF build. It's always been difficult to track down when that happens. I know what to look for now because LaTeX doesn't like Greek letters inside of formatting, inside of equations, which is apparently no longer a necessary practice. Always try to set up some kind of CI, even if it's a pre-commit hook, post-commit hook on a local machine, although you don't want to rely on that. Rely on CI. We like to use GitHub's review system as it was intended to be used, and I think if you do that, you'll also be in pretty good shape. The suggestions are very useful. You can actually make the changes that you're suggesting that somebody makes instead of just saying like, oh, hey, you should change this to this. You can just do it for them. And that greatly expedites the editing process and takes advantage of something you really can't do in virtually any other system. You can't just make a batch of changes or suggest a batch of changes. GitHub's really good for that. And other source control management systems like GitLab, Git and some others. This was not without pain. Some things were pretty easy to fix. Others were a little bit harder to fix. And of course, some are still as of yet unresolved. Dependency installation was a bit of a pain. The whole thing together, there's probably about 1.5 gigs to 2 gigs worth of downloads necessary. On our corporate VPN, that can be pretty slow. That can take like about an hour. On your like gigabit internet at home, it's going to be super fast. There's other ways of handling it. There's a package that I started playing with a little bit called Tectonic. It's a tech engine written in Rust that only downloads what it needs in order to build, but it has to have that connectivity at build time, and it'll cache the things that it uses. Learning Pandoc's flavor of Markdown it was not that hard, but Pandoc uses a different style of doing tables. It can use what it calls pipe tables. That's the prevailing standard for writing tables in Markdown. But there are some other more expressive ways of doing tables in Pandoc that allow you to, for instance, put bullet items inside of a cell in a table, and you can't do that in regular Markdown tables, regular Markdown pipe tables. We did get a little bit of feedback that people just wanted to use LaTeX, and while that would work for some people, it wouldn't work for others. So we had to establish some practices for the people who were really adamant about wanting to use LaTeX, and I'll talk about that in a little bit. Converting from Word or LaTeX to Markdown is lossy. Loses cross-references and it loses some other things as well. So we had to be careful about how people were importing work that they had already done in another format in anticipation of using that format for the project. Other productivity pain points. There's kind of an incomplete WYSIWYG story around this. It's easy to edit a document, and you can set up some systems that allow you to edit when you save. You have a PDF reader over to the side, and it'll automatically refresh in some ways. We've gotten that down to a pretty good science, but it's still not quite as good as a Markdown editor that's going to show you an exactly live preview, or something that's actually WYSIWYG like Word. There certainly are bugs in the workflow, bugs in the makefile that we've encountered. One of our projects, we have to have like a separate build process or a separate build script that eventually calls make because we weren't able to figure out how to do something in make. As being the only developer who was really working on the system, on the system itself, I was a bit of a bottleneck, and it was sometimes difficult to convey what was going on. The equation editing workflow was probably the most frustrating for our data scientists. Using an editor with tech equation support is super important for facilitating that. I like to use a separate renderer. I use LaTeX. You can also use mathjax.com. They have like a demo on there that works just fine. The other way to do it is just render the thing, and you have to wait a little bit. But remember, I said you can specify just only render this one file, so it goes a lot faster. We did have some objections. Some people were like, "Oh, I want to use ASCII doc," or "I want to use LaTeX." Well, that happens. But we had to say, you're going to own this. And there's some problems with that I'll talk a little bit more about later. The big thing is just making sure that you integrate it into a build system. The greatest risk, of course, is overwriting. Transformation output overwriting other version files bit us pretty hard a few times. In the subsequent use of this system, which I'll talk about later, one person strongly preferred to use LaTeX, and another preferred strongly to use our Markdown and convert both to Markdown. This went okay, but with some caveats. I recommend avoiding this entirely. Store the original document, so the LaTeX or the R Markdown, in the repository, and then modify the build system to be able to handle the conversion from that format to Markdown, or just trust Pandoc to be able to import that file correctly whenever you build the final document. I did get some good feedback from some folks. One person in particular gave me some good positive and some good negative feedback. Same person said, this really leveled the playing field for contributions. Great for collaborating and building documents with all of the features of LaTeX. Because that's actually true. When Pandoc renders a PDF through LaTeX engine, it actually converts to LaTeX internally and then passes that LaTeX off to the LaTeX compiler. Of course, the bad part of it was we didn't really have a lot of fine control of figure placement, of subfigures within figures, or positioning of diagrams, equations. They're just kind of wherever they are. And Pandoc just doesn't have the control of precise placement that he really wanted. Lastly, I'll talk about some current use. This is growing in adoption. Our leadership was very impressed with not only the document that we produced, but the system and methods by which we produced it. So that's saying something when you can do something, but how you did it was also novel. We've since expanded the use of this system to other teams, including one that was using a fork of my original repo as a basis for documentation spanning several different teams. I think there's 8 repositories involved in it. Content is brought in through Git submodules, which has its own set of problems, but is ultimately a fairly good thing, where each repository is actually its own document. And then we can build the big document that has several hundred pages. At least one person was working on a book and inquired about using it. That's awesome because the basis of this system was what was used to write the first edition of A Friendly Introduction to Software Testing by Bill Laboon. We used many tools in the process. Notably Pandoc. We wouldn't have been able to do this without Zatec. Make is a key player. Git makes us able to pass things around. Lots of cool tools that aren't even on here. In the future, my long-term vision for this is to have a single source for this document system that gets turned into a bunch of easily consumable formats, creating a searchable archive, a searchable library of sorts, kind of like archive.org, for all of Target's internal scientific documents. And we have a lot of them. And then there's some style. Our documents use mostly out-of-the-box Pandoc stylings, which is more or less out-of-the-box LaTeX stylings. I'd like to leave Computer Modern as the font because it just conveys a certain air of respectability. But I'd like to put a little more Target red everywhere. So, in short, go check out Pandoc at pandoc.org. It's a very well-covered subject on Stack Overflow and a few other sites. Of course, some references and attributions. I did use some icons from Font Awesome. And then, of course, Friendly Introduction to Software Testing is the name of the book from which a lot of this is derived. Really the build system of the book. He doesn't actually talk about the system in the book. You can find the raw source for these slides, including the build system that's built around Pandoc in my GitHub repository there on the slide. Then a rendered version of this is available on my speaker deck profile. That's it, folks. Thank you very much for watching. I'm Colin Dean, and that's it. Cheers. Goodbye.